Oh yeah, Max.
Morning, Professor.
Be right back. Get my second coffee of the day.
Coffee, what's that?
Coffee is something I didn't used to drink till about a year ago.
I've been told I'm a heathen in regards to not drinking coffee at all.
Oh, I was the only person in my family who my family of origin who didn't drink coffee. Either my wife or I drank coffee. Um, yeah. But I started drinking those um uh, what are they, mocha lattes that McDonald's has and that Starbucks has, and I really like those. And so I started making them myself at home with Keurig, my daughter got, and from there I thought, well, let me try it without the milk or the cream or whatever I was putting in it. And yeah, with enough sugars, it was fine. So
A lot of times with enough sugar, just about everything is fine. But I think the last time that I drank anything coffee related was probably one of those cold drinks from Starbucks that you'd find at any convenience store.
yeah, well, that's why I started drinking was those the Starbucks mocha lattes that were in the refrigerator section. Yeah. Please put your name in the chat. Do not use direct message because it doesn't show up when I take roll. What, kitty cat? Come on. You gonna come up here? Come on. Come on, you beast. Yeah. This is the newest addition to our household. And he's a big one. Yeah. See, look over there. Look over there. You see over there? Dumbass cat. All right. Now, a friend of my daughter's, this used to be her cat. She had this cat for 5 years. She moved to Texas from Alaska and brought this monster beast with her. Has paws the size of snowshoes. Anyway, but she had a baby, and it turns out the baby is allergic to cats. So my daughter, being the person she is, we took the cat. So
Oh, that's sweet.
we kind of renamed him a little bit. His name was Ruger. We're kind of don't care for that particular name, so we call him Rue or Rufus or Rupert or something like that, but we usually call him Rue. He really doesn't answer to it anyway, but he's a funny.
I like
awful-
Rue.
He's
That's a good
pretty
name.
vocal, and he likes to jump up on my desk. He likes to use my desk as a starting point to go up higher and knock things off of the top part of the desk. We have where is it? This is a little Katina doll that he knocked down and broke various pieces. Oh, yeah, broke the leg off. And he's missing his arms and one of his ears. That he just knocked it down and it broke. And I can probably glue it back together, but anyway, please be sure you put your name in chat as you come in. Do not direct message me with your name because it won't show up when I take roll. Zoom used to not do that. It used to show me all of the chats, but right now it's not showing me the direct messages. So I don't know if that's in the settings that I can change it, but I've looked through the settings and I haven't been able to determine if I can have it show me everything. So because previous semesters direct messages showed up anyway. So this class has 24 people in it. We got 17. There's another person who's going to join us. They got dropped from the class for whatever reason, and they're going to see about getting back in. Okay, I got all kinds of drinks in front of me. I've got my cup of coffee. I got my, well, the tail end of a glass of tea and my fruit punch. Anyway, so that way I stay, my throat doesn't dry out. And I'm just waiting for a little bit more people to come in because we're at 19. Well, actually 18 students. Now we're at 19 students. So we need 5 more people. And this will give me, well, I should be getting things ready to go. And I do have them ready to go. I just haven't pulled them up. Zoom needs to come back up. There we go. Anybody have any questions for me while I'm waiting for a little bit more people to show up? Questions about the homework or anything? We really haven't. This class especially, we've just got to slide 7. That's barely anything as far as the homework is concerned. So so that you could go in there and start the homework. As I've stated before, you have an unlimited number of tries at the homework assignments. And as you're working through the assignments, you have 3 attempts at each problem. So that's how that works. Yeah. And as I've said before, I prefer that y'all be on camera during class time and definitely be on cam. And I will fuss at you if you're not on camera during an exam. But as far as during regular class time, if you're not on camera, sometimes I'll say I need y'all on camera, or I prefer to see my students' faces than a screen full of names. Because I don't know, I can gauge reactions better if I can see your faces. Let me put it that way. And sometimes I ask a yes or no question, and it's easier to see nodding heads than it is if you're on camera than if you're not on camera and you're nodding your head. So yeah.
How do we get to the homework again, sir? I'm sorry to
Okay.
interrupt.
All right. Let me pull that screen up. And here we go. Okay. So let me share that screen. Ooh, there it is. Yeah. And I gotta make that go away. Anyway, so you go to this class in Canvas and Alamo Books. You click on Alamo Books, the link over here on the left-hand side, and it takes you to, I think I got too many things open up here. Let me close those. Yeah, I have stuff open from. Okay. So, okay. Oh, they've taken them away. Okay, there used to be another, and there would be another thing here, but this is the one you use. The Read Now is just the textbook. Well, it has some instructions in there about how to do this, but you click Launch Courseware and it takes you out of Canvas and it takes you into Pearson eventually. And if you haven't already signed in, this is where you sign in. If you have a Pearson account, this is where you sign into your Pearson account and it puts you into My Course. At no point should you have to enter any key code or passcode or anything to get into My Course, because this will take you straight there. Once you sign in to your Pearson account, or you create your Pearson account, then it'll take you to the course. And once you've done that and you've already signed in, then this is periodically it'll keep asking this. And I don't know why. Oh, geez. Yes, I do. Hello. See,
Yeah, it did the same thing to me when I was on there. I wasn't able to just go straight into the home screen on my MATLAB. So I just had to click homework and assignments, and that way I got in.
Now, how'd you get in?
Instead of clicking open at the top, I hit that little, it's kind of like a link to at the bottom where it says instructor tools. This is my math lab course for not that one.
The course manager? Or
All
the course home?
assignments, the student links. Because we don't see the instructor ones, we see the
Okay,
student
so
ones.
you click here?
Yes, the assignments, and it takes us to, or it takes
Yeah, it's
me.
gonna do the same thing again with me. What are you doing? Well, sometimes my machine is really, I don't know why it's doing this to me today. But it does that to me periodically. It should just take me straight in there.
I think all you have to do is just enter in your stuff, like your login for school, like,
Yeah,
and then you should only have to do it once, and after that, you should be able to go straight to it.
right. Yeah, and I should. Here's my login name. No, I have them in there. Oh, well. I'm not gonna worry about it right now. But yeah, it is supposed to just take you straight in there. So I don't know why it's doing it to me today. So let me see over here. See if this will let me do it. This is a different class. It's the same course, but it's a different class. And nope, it's doing it to me here too. Okay. Well, I'm not gonna worry about it right now.
Professor, I have a question.
Yes.
So when it comes to like our quizzes and our tests, is that something that we do during our class period, or will it be something we do on our own time?
Nope. Do it in class.
Okay.
So
I was wondering if you knew when the first one would be, because I do have an appointment on the 10th, and I know that's right during our class time
the 10th of what?
of February.
Okay. There will not be an exam the 10th of February.
Okay, thank you.
There will be one around that time, but I don't think it'll be on the 10th. Well, is the 10th a Wednesday?
A Thursday.
Oh, it's a Thursday. Yeah, I had worked out this. I haven't translated into transferred those dates into Canvas yet. I have them, and no, the PowerPoint hasn't been posted yet. I apologize for that. That's something I meant to do by now for all my classes. Okay. Please be sure and put your name into chat. Don't direct message me with your name because it won't show up, as I found out last week sometime that the direct messages don't show up in my, when I go to Zoom. Let me see. Yeah. When I go to Zoom here and I click on cloud recordings and I go to the, and this here is the chat file, direct messages, and this is where I take attendance from. In the chat file, it doesn't show the direct messages, which is very frustrating, very annoying. Anyway, I'm going to stop that share and pull up some other stuff. So first thing I'll pull up is that, and then I'll pull up this. And then I'll put my Zoom meeting back up. Yeah, I'm working off of 2 screens. My camera is over my second monitor and everything else is on my computer monitor. So if I'm looking off this way, means I'm reading off my computer. I'm looking at my computer screen, not the monitor where y'all are. Yes, I know I just made a lot of noise. All right, so the next thing here is to start with this. Advanced screen share, which is a portion of my screen. So let me do this because I can't make this bigger. So, but why is it shoving that out of the way? Oh, because I have a hold of the wrong thing. Okay, that's right. All right. Okay. So my phone, which is my timekeeper, I have it over here, so right in front of me, so I can see what time it is. It's kind of blocking my screen over here, so I may not see what, if someone asks me a question in chat, please direct my attention to it if I don't respond to it in a timely manner. Oh, so this is a slide we ended on. Let me back up a slide. Okay, so we talked about angles and quadrantial angles. Quadrantial angles are angles that lie on the X and Y axis. Okay. We talk about angles that fall in a quadrant. So this angle here, which looks to be approximately 135 degrees, which is 3 pi over 4 radians, is a second quadrant angle. Okay, all the angles between 0 and 90 degrees, not including 0 and 90 degrees, are first quadrant angles. Those are very important angles. Those are our reference angles, and we'll talk about that more later. So this one wound up in the fourth quadrant, so we say that this theta is a fourth quadrant angle, and it looks to be approximately a negative 45 degrees, or negative pi over 4. And then this is a quadrantial angle. Since we're going counterclockwise, it's a positive angle, and it's that's 270 degrees, or 3 pi over 2. So 1 degree is 1/360th of a revolution. So 1 revolution is going around once, and that would be 360 degrees. Of course, that means we wound up back at 0 degrees. Okay, so 1 degree, which I really can't draw here, but I can kind of, this here being 1 degree in here is 1/360th of 360 of 1 revolution. Okay. So 90 degrees is a fourth of a revolution. A straight angle is a half of a revolution. So we can talk about, you have revolutions or a portion of a revolution. Okay. How many times does it revolve around? And please realize, with angles, we can have angles that are larger than 360. All that means is that it went around once, and then it started. So it could come back to here, or it could have come all the way back around again. And so it would be 720 degrees, or it could come all the way back up over to here again. And so that would be 720 plus 90, which is 810 degrees. Boom, boom. Okay. So we have those situations. So they ask you to draw each angle. Usually to freestyle an angle is not so easy. So I always start with drawing a coordinate axis. 130 degrees is 45 plus 90. So that's going to be this angle here. So 90, and I go 45 more degrees this way. So that's this angle here. So this is a 135 degree angle. Okay, a negative 180. Well, we're going in the negative direction, which means we go clockwise all the way over to here. So that's 180 degrees negative. We still wind up at the same place as if we went a positive 180, but direction is important. Okay. 90 degrees means we just go up here to this, and everybody knows what a 90 degree angle is, especially those who've gone through geometry. It's a right angle, 90 degrees. 495 degrees means we went around more than once. It means we went more than 360 degrees. So how much more did we go? So I do 495 minus 360. Well, that's going to leave us 135 degrees. So we're going to go around once. That's around once, and then keep going to 135. So this was 495 degrees. We wind up at the same terminal side as 135. So when we start talking about the trig functions, 135 degrees has the same values in trig functions as 495 degrees does. So when you start talking about the trig functions, we don't care about how many times it goes around. We're concerned about where it winds up. When we start graphing, yeah, we're concerned about how many times it goes around, but that's how we look at it. That's when we start looking at the cyclical or the periodic nature of trig functions. So, and they do it from standard position. Yeah. Oh, okay. That's what they said to do. Standard position. That's what I did. So it's 1.5 right angles. So one angle and then a half a right angle. That's an interesting way of looking at it. Okay. An angle of negative 180 is half a revolution in a clockwise direction instead of the counterclockwise. And then an angle of 90 degrees is 1/4 of a revolution. So we wind up on a quadrantial angle. So 90 degrees is a quadrantial angle. And so is 180. Negative 180 is a quadrantial angle. And then the 495 degree angle is the same. It winds up in the same place as a 135 degree angle. So we do one complete rotation, and then we do another 135 degrees. Okay. So now we're going to start talking about degrees, minutes, and seconds. Right? If you know anything about navigation, they talk about degrees, minutes, and seconds. All right. 1 degree on for navigational purposes is 1 nautical mile. So that's where the nautical miles comes into play when they talk about knots. How many knots are you traveling is a nautical term, and it's about this thing that 1 degree takes 60 minutes. So this is the same as 60 minutes. This is the same as 60 seconds. And so that makes this the same as 3,600 seconds. Because each of these minutes has 60 seconds. So 60 times 60 is 3,600. Yeah, right now I have that tune from Rent running through my head. Okay. Now, to convert this to decimal, all right, so each minute can be written as a decimal of degrees, all right, and the seconds can be written as a decimal of minutes and as a decimal of degrees. So how I do this conversion here is slightly different than the way the textbook does it. So what I do is I convert the seconds to minutes, and then so that would make we have 65 degrees, 9 minutes, and 17 seconds. So I convert the 17 seconds to a decimal portion of minutes, and then I take that decimal number of minutes and convert it to a decimal form of degrees. Each case along the way, I'm dividing by 60, because 1 second is 1/60th of a minute. So 17 seconds divided by 60 gives me minutes. And so I do that division. Let me go and do that. Let me do that right now. Gotta turn my calculator on. Yes, you're allowed to use calculators. You're allowed to use a calculator on the test. I do not want you using your phone as a calculator. I have, oh, you can't see it. There it goes. This is a Casio. It's a scientific calculator. All you really need for this class is a scientific calculator. The department says you're supposed to have a graphing calculator. Well, I don't, unless you're going to do stuff more serious and later on with other classes and stuff, I don't see a need of investing that $100 or so for a graphing calculator when you can buy a decent, well, the cheapest, as a matter of fact, I have one. I can't find it. I misplaced it. I have and I prefer the TI. I have a TI 30A. TI 30A, and there's several different versions of this, okay? But I have the real basic one, which is all you really need for any math class. It has all the trig functions in it. It has logarithms in it. It has all kinds of nice stuff in it that you really don't need for other things. It has a memory in it. It has, so if you're doing stats, you can use that calculator in stats. But the way the course is taught, the elementary stats is taught, it's really better to have a graphing calculator or use Excel. When I used to teach stats, I didn't have them use a calculator at all, other than using it to punch numbers around. Okay. And this one, this cost, I think it's up to $11 or $12 now. It used to be at $10, but that was several years ago. And with the advent of COVID, prices of everything has gone up. Okay. Oh, I was going to divide here. So we do the 17 divided by 60, and that's approximately 0.283 repeating. So I'm going to round it to 3 decimal places. So now my so 9 minutes plus 0.283 minutes gives me 9.283 minutes. Now, each of those minutes take that away. It doesn't need to be there. If I divide this by 60, that will give me the number of degrees in a decimal number. So what I'm going to do is, now I'm going to divide this number by adding this to 9, and then I divide that by 60. And I get 0.1547. So now this is the number of degrees, the decimal portion of degrees. This 9 minutes and 17 seconds is that many degrees. So now we have 65.1547 degrees. Draw a line here.
But you
And we
added,
have-
so you took the 0.1547. Oh, okay, and just added, I see what you did, never mind.
Yeah, I did. So I end up doing the 65 degrees plus this. I just do it a piece at a time and then add it all together. Or I add it as I'm going along. I converted the seconds to minutes and added it to the minutes, and then I converted the minutes to degrees and added it to the degree. So 65 degrees, 9 minutes, and 17 seconds is the same as that. And realize since I rounded somewhere, like this is actually a 3.333 forever. And so I rounded it to 28.3. I mean 28.3. Oh, this up here, sorry. So I rounded it to the 3rd decimal place. Now the next number they want you to convert is, they want you to convert a decimal number to, it'll be 32 degrees something minutes and something seconds. And yeah, here they wanted to 4 decimal places. And so, yeah, I rounded it to 4 decimal places without realizing that's what they wanted. So I probably should have kept some of those 3s here when I did that, because I want to use more decimal places than they want me to round to, so I get a more accurate number. So the number I have here might be a little different than what they have, simply because I rounded before the last number. And that's something I tell people is you round at the very end. And if you need to round while going along, you need to go double try it. So they want us to round to 4 decimal places. So I want to keep 2 or 3 more. So I go down to 7 decimal places and use that. So what they do is this 1 degree is 1/60th. I mean, this 1 minute is 1/60th of a degree. So 1/60th degrees is the same as 1 minute. So I multiply that. I'm multiplying by a fraction. And then 1 second is 1/60th of a minute, which is 1/60th of a degree. So 1 over, didn't I say that here? Like this right here? So this is 1 over 3,600. And so they convert everything to a degree and then add it all together. So I have people who prefer to do it the way the textbook does it, which is fine. You know, you do a method that makes best sense to you. For me, I like to do it a piece at a time. I make fewer mistakes that way. That's all. And so they're doing that conversion here. So 9 times 1 over 60, and then 17 times 1 over 3,600, or 17 divided by 3,600, and 1 divided by 60, 9 divided by 60. You get 0.5 degrees, and you get 0.0047. Okay. And this is a rounded number. This 0.0047 is a rounded number. Please be aware of that. Because dividing by 60, unless 3 divides the number on top, you're going to get a repeating decimal. Okay. And then you could just combine those to get the same thing I did. Now this, we're going to end up going we're going to do it slightly differently. So I'm going to convert the 0.479 degrees into minutes. I mean, into minutes. And it'll be a decimal number, right? So that means I multiply by 60. Here, I divided by 60 to make it into a decimal. Well, to convert this decimal back to the other, I would multiply this number by 60 to get this number in the numerator, this number right here. So I'm going to multiply 0.479 times 60. And that gives me 28.74. The 0.74 is the number of seconds as a minute. So the number of whole minutes is 28. And so now I'm going to convert this point 0.74 minutes to seconds by multiplying it by 60. Uh-oh. Sorry about that. This is something it does every now and again. There we go. So I'm going to multiply the 0.74 times 60, which will give me the number of seconds. So 0.74 times 60 gives me 44.4 seconds. And they asked to round it to the nearest second, didn't they? I think they asked to round it to the nearest second. So this is approximately 44 seconds. Let's see if I remembered that correctly. So they rewrote it as 32 degrees plus the 0.479. Okay, and then they're going to multiply that times 60. Because that's 1 degree. That's how many, that's the portion of 1. And so 1 is 60 minutes. And so that gives us the 29.74 minutes. So now they're going to rewrite this as 32 degrees plus 29 minutes plus 0.74 minutes. And now they're going to convert this minutes to seconds by multiplying. All right, so they factored out the minute portion. Okay, yeah. Which gives us, they want it to the first decimal place. I can't remember. No, they wanted it rounded to the nearest second. Okay. Which is the same thing I got. Okay. And now for something totally different. We move on to arc length. All right. We have a circle. We have a portion of a circle. And this part of the circle, let me use a different size. This portion of the circle, Thomas, is the arc. An arc is a part of a circle. Okay. And so we call the length of this arc length, we call this arc length S. Okay. So arcs are created by the intersection of a central angle. Central angle comes off the center, and the circle. So this angle has a degree of theta, and theta, for this formula, theta is in terms of in radians. So it'll have pi, or be some portion of pi. Okay. And here we have the radius. And so S, the arc length, equals the radius times theta. Well, if you think about the circumference of a circle, the circumference of a circle is 2 times pi times r. 2 pi. That's 1 time around the circle is 2 pi. So a portion of 2 pi is what S is. So what portion of 2 pi are we dealing with to get that? Well, that portion is theta. So theta times r, or r theta, gives us our sector length, because that's the portion of the circumference. Right. So now they're saying that r is 4 meters, and the central angle here is 0.75 radians. All right. So we just use this formula. We know the radius is 4. We know the radians is 0.75, right? Which is going to be 3. So it's 3 meters long. The sub-ended, well, that's what this angle does. It creates, it cuts out a part of the circle. Questions there? All right, this is the plug and chug. A lot of this is plugging and chugging, but it's knowing which formula to use. Okay, and the secret behind formulas is understanding what the symbols mean. And now I'm out of coffee. Okay. So that's 3 meters. Now we're going to talk about radians and degrees, converting between radians and degrees. Let me make sure. Okay. 1 revolution, 1 time around the circle, is 2 pi radians, which is the same thing as 360 degrees. Because 1 time around in a using degrees is 360. So, and they didn't say this. 360 degree is the same thing as 2 pi radians. Okay. We sometimes abbreviate radians as rad, but we pronounce it radians. And so half of that would be 180 degrees equals pi radians. So from this, we can come up with these two. These are called unit fractions, because this fraction equals 1 and this fraction equals 1. Because pi radians and 180 degrees are the same measure. They're just using different units. So it's the same length, the same angle. So it's 1. That's why we call it a unit fraction. And we used unit fractions to convert from 1 unit of measure to a different unit of measure. If you took chemistry in high school, you've done what's called dimensional analysis. Does anybody remember that? Okay. I didn't actually take chemistry in high school, but I did dimensional analysis in chemistry in college. And when I did a very short stint as a chemistry teacher in high school. And I tutored some students in chemistry. Actually, I think I learned more chemistry by tutoring than any other way. Dimensional analysis is just converting from one unit of measure to another unit of measure. It's like I'm converting from feet to inches. That means I'm going to multiply by 12. I'm converting from inches to feet. That means I'm going to divide by 12. I'm going to multiply by 1/12. So that's what we're doing here. So if I divide, and let me write it this way, 180 degrees is the same thing as pi radians. If I divide both sides by 180, I get that first one there, which is 1 degree, because 180 divided by 180 is 1. It is not, as some ninth graders think, it is not 0. And then you get pi divided by 180 radians. So if I want to convert from degrees to radians, I multiply the number of degrees by pi over 180, because it takes the degrees out of the problem, out of the measurement, and puts radians in the measurement. Now, if I want to go from radians to degrees, then I would divide by the pi. So that means 180 divided by pi degrees equals 1 radian. So if I multiply the number of radians by 180 over pi, that's taking the radians out and putting the degrees in, because 180 is the degree where pi is the radian, right? And that's how come it works this way. So if I'm given X number of degrees and I multiply it by pi over 180, that gives me a number of radians. And we almost always leave the pi in there and just deal with a fraction. And if I do the number of radians times pi over 180 over pi, that's pulling the pi out of the radians and putting the degrees in. And so that'll give me the degrees. So we have 45 degrees and we have 210 degrees and a negative 60 degrees. If it's negative degrees, it's going to be negative radians. That should be a no-brainer. And then we have 100 degrees and then 109 degrees, right? So to convert from degrees to radians, we need to multiply by pi over 180, right? Dividing by the 180 takes the degree away, and multiplying by pi puts the radians in play. So this is 45 pi over 180, and that's radians. And you simplify the fraction. You reduce the fraction. 4 times 45 is 180. So this is the same as pi over 4 radians, or pi fourths radians. And again, on each one of these, A, B, C, D, and E, because we're converting from degrees to radians, we're going to multiply each one of these by pi over 180. So that's going to be 210 over 180 times pi. All right, so this is going to give us this will reduce to an improper fraction. Okay, it's always going to be a fraction unless you're asked to round to a certain decimal place. It's going to be a fraction answer unless this winds up being a whole number here. Okay, this is radians. Okay, so I'm going to work this out down here. So the 210 over 180, well, those two zeros can go away. Thank you, Mrs. Aldrich, my third grade teacher who taught me that trick. Because that's just dividing by 10, both numerator and denominator by 10, and or factoring out the 10. So you have 21 over 18. Well, 3 divides both of those, so you get 7 over 6. So this is 7 pi over 6 radians. You're going to have to become very comfortable with fractions. If you're continuing on into calculus or some other science-based field, fractions, you're going to have to be very comfortable with dealing with fractions, adding, subtracting, multiplying, dividing, reducing, changing. So, yeah. So on the next one, we're going to end up doing the same thing. We're going to multiply by 1 over 180. So you get a negative 60 pi over 180. Well, that's easy, right? Radians. I forgot to write the radians. Usually, after we get past this point here, if you have pi in the number, you don't necessarily need to write the word radians. So the zeros disappear and it's 6 over 18. Well, that's 1 over 3. So this is a negative pi over 3, or negative pi thirds. With the 100, again, we're going to multiply by pi over 180. So that's going to give us 100 pi divided by 180. Again, I lop off those 2 zeros there. And so I can divide by 2 in the numerator and denominator. And that gives me 5 pi over 9, or 5 pi ninths radians. Again, I keep forgetting to write the radians. I'm so used to not writing that word when I use pi. Now with the 109, because it doesn't divide nicely, what they're going to end up using is punching it into the calculator. And so you have 109 pi divided by 180 radians. Now, they're going to, they didn't say this here and they didn't talk about it, because 109, the 109 is actually a prime number, so it won't simplify. So if this was a question on a test from me, then this would be your final answer right here. Unless I say round your answer to the nearest to the second decimal place, the nearest 10th or the nearest 100th, that type of here. But they didn't say that here, but that's what they end up doing. And I forget how far they go. So in the calculator, this is what I'm pressing. And I'm using my TI calculator. Well, it doesn't matter. It's any calculator. So, whoa, that is not plus, that is times. Okay. So what I did here is I did 109. Let me write it a little bigger. 109 times pi, because my calculator has the pi button in it. A good, well, any let me see if I have it right handy. Any calculator, scientific calculator, will have pi in it. Looking for, I have these little, oh, here it is. Yes. I don't know if they still have it, but there was a Dollar Tree up by me, or a dollar store, I don't know which it's called, had these little scientific calculators. Okay. They're tiny, tiny, tiny little things compared to this one. Okay, they're small. So it does every single thing this calculator does, this one does. The difference is this one costs about $12, $14, where this one costs $1. Okay. Yeah, you're buying something, an electronic device for $1. Guess what? It's only worth $1. That means that when the battery runs out, don't bother about replacing the battery, just buy a new one. It's only $1. And please be aware of the fact that, and I've had this issue because I have a bunch of these that I used to cart around to every class I taught, so people could have them if they didn't have one, handy. The buttons, sometimes at random, will stop working because it's a dollar calculator. The quality is not there. And so I had one that during the middle of a test, the 3 quit working on a person. So they came up, handed me that one, and borrowed another one. I had plenty that for those who didn't bring their own calculator. And so I would just end up throwing that one away because I can't fix it. So, yeah. Oh, and then we divide by 180. And so this will give us the radians. All right, pi puts the radians in. Dividing by 180 takes the degrees out. Okay. On a TI calculator, divide shows up as a fraction bar. And this is going to be 1.74 approximately 1.745 radians. I rounded to 3 decimal places. I don't know how much they round to. They might just round to the 4. When in that case it would be a 5. You can't see me pointing at my device. Okay. So they multiplied and simplified the fraction. They multiplied and simplified the fraction. So they're getting the same values I did. And same thing here. If it started out negative, it's going to stay negative. And so C, yeah, 5 pi ninths, or 5 pi divided by 9. My boss, when I was over at SAC, and I talked about fractions where I would have 5 pi over 9, and I used that phrase at the end of class. He came up and said, yeah, everything you're doing was great, but when you talk about fractions, talk about them correctly. The 5 pi over 9 is not 5 pi over 9, it's 5 pi divided by 9, or 5 pi ninths. So I'll say it, if he's in the room, I'm going to say it, I'm going to use the right terminology, but I'll switch around with it. So And then the next one, all right, they went ahead and, whoa. How come I got different? Probably because I used 100 instead of 109. Yeah. So that's 902. When I type it in the calculator, this is what I got. 024, Thomas. 40885. But they rounded to the third decimal place, so they only looked at the 4 to determine if you stay at 2 or go up to 3. And so that rounded to 1.902 radians.
Sir, I got 1.901 radians. I don't know if that makes too much of a difference.
What did you use for pi?
For pi, I use 3.14.
Okay, that's the problem.
So do you want us to extend it to the,
3.14 is a rounded number.
so do you want us to extend it to maybe like the 5th significant figure?
Well, does your calculator have the pi symbol in it?
I'm not able to locate it on the actual calculator.
Okay, so is it a scientific calculator?
Yes, I just found it right here.
Okay, okay. So use the pi button. Yeah. You don't have to use a graphing calculator, just any calculator that has the trig functions on it and has pi on it. Yeah. So the first scientific calculator I bought cost me $10.
Hello, sir.
And that was way back in the 70s.
Hello, sir.
Yes.
Yeah, so I'm trying to calculate it on my calculator, but it just seems that it's just bringing up the fraction instead of like the decimal. I'm not really too sure.
Okay.
But it's-
On my cat, damn cat, on my Casio, there's a button that what type of calculator is it?
It's a Casio. It's a Casio F dash 300 ES plus.
Okay, that's what I have.
Okay.
The only I think mine's solar powered. Is yours?
Yeah.
Okay, it's just manufactured a different year so it'll look a little different. There should be a button on there that has S with a double arrow with a D following, right above the delete button.
S with a double E. Can you?
All right, it kind of looks like this. It's not showing up there. There it is. Yeah, this here.
Oh.
You hit that, it'll change from decimal to fraction, fraction to decimal.
I don't. I'm trying to look for it. I don't see it. Yeah, I just need to look at their instructions.
All right, so on mine, that button is right there.
Oh, yeah. I see. Okay, now I see it.
Okay,
I got 1.9. Yeah, I got the same.
okay.
Thank you, sir. I really appreciate it.
Most Casios, well, the Casio graphing calculator does exactly everything the TI graphing calculator does. It's just the difference is how you use it, how it gets you where you need to go. And so it's the scientific calculators are pretty much the same. It's just there's some differences, but they're, it's just like I know in the TI calculators, there's a way to flip back and forth between decimals and fractions, but I've never been able to use that notion. But okay, moving on. Now, to convert from radians to degrees. Now instead of multiplying each of these by pi over 180, now we want to take the pi out and put the degrees in. So that means we're going to multiply each one of these by the unit fraction 180 over pi. So this is going to convert it from radians to degrees. Whoops. Can't even spell degree. So the first one is pi over 4 times 180 over pi. And what happens is that the pi's go to 1, so they disappear. And so now this is just 180 divided by 4, which is 45 degrees. And we tack the degree symbol on there because it became degrees. And so each one of those, the same thing happens. So 7 pi over 6 is the pi goes away. You divide 6 into 180, which is 30, and 30 times 7 is 210. So 7 pi over 6 is the same as 210 degrees. Right? Because you have the 7 pi over 6 times the 180 over pi. The pi's go to 1. 6 goes to 1, and the 180 goes to 30. And so you're just left with 7 times. Well, that was smart move there, Cat. Maybe you'll stop jumping up there. Only problem is I have to clean up the mess he made. Okay. Stacks of paper just went falling down. Okay. And so that's 210 degrees. My other little cat is just looking around like, what just happened? Go back to sleep. I call her Puppy because she follows me around to every room in the house. If I change rooms, she'll follow me. Sometimes she'll lead me, telling me she wants me to go out in the front patio and let her go out there. So she's funny. All right, and then the negative pi over 3, again, it's a negative angle, so it's still going to stay negative when we convert it to degrees. So that's time 180 over pi. And again, the pi's go to 1, and 3 divides 180 60 times, but it's still going to be negative. All right. And then the 5 pi halves times the 180 over pi. Again, this is it's gonna take the radians out and put the degrees in. So the pi's go to 1, and 180 divided by well, there's 2 ways of working this. Half of 180 is 90, and 5 times 90 is 450. So that's 450 degrees, or 5 times 180 is 900, and 900 divided by 2 is 450. So either way you get there. And if you punch it in the calculator, it doesn't matter because it does all the heavy work. Okay. And now we have 2.5 radians times 180 over pi. And I'm going to punch that into the calculator as 2. Whoa. Uh-oh. Hate it when that happens, because it interrupts the flow. 2.5 times 180 being divided by pi. I punch that into the calculator and I'll get a decimal number. Wait, yeah, divide by pi. And let me do that. So 2.5 times 180. Oh, I forgot to press the times. 2.5 times 180 being divided by the magic number pi gives us 143.239 approximately. I rounded to 3 decimal places. If I wanted to round to 4 decimal places, I mean to 2 decimal places, it'd be 24. Do they go to 4 decimal places on this one? They might go to 4 decimal places on this one, but I don't remember. So we're gonna quickly go through their calculations, and pi fourths is 45 degrees. 7 pi 6 is 210 degrees. Negative 3 pi thirds is negative 60 degrees. 5 pi halves is 450 degrees, and 0.25 radians is when they rounded to the second decimal place. So that's why they got a 4 there. Now, if you're told to write something as a decimal and you're not told to round it, I will always tell you to round it to a certain decimal place. If I want you to write it as a decimal. So will the textbook. So they'll specify how many decimal places. They don't always do that in their slide presentations. And 3 decimal places is better than 2. Okay. So with small, here we go. With small angles, what we're talking about here. All right. I'm going to draw a bigger picture than what I need to explain this. So here we have this arc. Okay. So the arc is subended by a central angle. That means it hits the circle at these 2 points, and the portion of the circle between those 2 points is the arc. There's a chord that connects those 2 endpoints. A chord is a line segment that connects 2 endpoints. The endpoints of the line segment are on the circle. The diameter of a circle is a special case chord, because it's the only chord. The diameter is the only chord that goes through the center. But when we talk about chords, we usually don't talk about diameters as a chord. We talk about diameters as diameters. But they're saying if this angle is sufficiently small enough, this arc length and this chord length are very close to each other, so close to each other that we don't have to talk about their difference. Okay, so that's what they're talking about here, is that that arc, the length of the arc, is approximately equal to the length of the chord. It's going to be slightly larger, but not by much. Ouch. I'm afraid I'm getting arthritis in this shoulder. Okay, so we use that fact to talk about if we have. Let me go to the next slide. All right, so we have a 400 millimeter camera lens can see what's the width, field of width at 725 feet from the camera. What's that viewing? What's inside that camera? What can we see at 725 feet? So what's that distance? And so we know that angle is 6 degrees 9 minutes. So that's a that's a small angle. Okay. And so we're going to find this arc length, which is going to approximate this chord length. So S in this case equals the radius times the angle. And the angle has to be in radians. So this isn't radians. So we need to convert that 9 minutes to degrees so I can convert the degrees to radians. So this is a multi-step problem. Get used to it. Okay, so 9 degrees, if I divide it by 60, 9 minutes, that'll give me, divide by 60. That should be a 6 there, Thomas. That'll give me the number of minutes. Well, that's not approximately, that is 0.15 degrees. So this is 6.15 degrees, which I'm going to multiply by the fraction pi over 180, which turns it into radians. And so I'm going to end up rounding numbers. I'm going to start out by rounding to 4 decimal places. And the field, the width, they want to round that to the nearest foot, if I remember correctly. And so we do the 6.15 times pi, divide by 180. And I'm going to write it down to 4 decimal places. So I type in 1.15 times whatever pi, and my calculator calculates it down to, I think, a little bit more than 8 decimal places, more than what it shows on the screen. And then I'm going to divide by 180. And this is approximately 104.98155. Okay. So that's what theta is. So if I do the radius times 104.98155, actually I'm going to do 4 or 5. I'm going to use the calculator rounded number because I'm just going to multiply that by 725 because that's the radius. And so that gives me, is that right? That is not right.
Hello, sir.
Are we supposed to multiply 6.5 by pi and then divide by 180, right?
Yeah, I just noticed that I
That's
have
totally different.
60.615. I didn't hit the decimal, I hit the 1. I mean, I hit the 0.
Oh,
That's a mistake that can happen. So what I typed into the calculator was this, not this. So those mistakes happen. Just as long as you catch it and correct for it. So yeah, so I get a decimal number here, not a, so it's going to be 0.1073377749. So I'm going to multiply 725 times whatever theta is, which is this number. So I'm not going to write it down. I'm just going to do that number times 725. Yeah, okay. Is that right? Let me see. Okay, so yeah, I like their picture here. Their picture is very nice. So this distance here that's the radius, which is 725. This angle is 107 radians, 0.10 radians, 07 radians, and they multiply that times the 725. Well, I got a different number. The number because I multiplied by this number, I got 77.81986.802, which is a little bit further than what that's saying. Okay, since the arc length is a slightly larger than the chord length, well, they just left it at that. They went to 3 decimal places. So I like to use as many decimal places as possible and round at the end. So I would have gotten 77 point, and they went to 3 decimal places. So that would have been 820, because this 8 means we go up to the next number, which would have been 10. So I added the 1 to the 1 and gave me 20. And I put the 0 there because that tells me that's the place I rounded to.
Sir, for the exam or quiz, will we be expected to round to the 4th or 3rd decimal?
I'll tell you.
What,
Yes, sir.
what is it? Why is the example giving us something different, like 77.57?
Because they didn't use this number in their calculation, the number I used. They did 725 times 0.107, not times 1.07337749. I multiplied by a larger number than what they multiplied by.
Okay. I just wanted to,
So they got a different number than I did.
So if this was a test or a quiz and I got,
If there's that difference there, and I saw what, and you show me what you're putting into the calculator. So in your work, you have to show me what you put into your calculator. Then it's good.
yes, sir.
So if this is the number you're going to use in your calculator, then show me that you're multiplying by this number. If you're going to multiply by this number, show me that you're going to multiply by that number. So if your number is different than mine, then I look to see how you calculated it. And if it's just because you rounded at a different time than I would have, then I'm not going to penalize you for that. Okay. So if like in my answer key, this would be the answer, but you got different than I did, which they got a 77 point what? 575. Well, that's not a whole lot of difference there. That's less than a foot difference. Okay, so that's, you know, that's nitpicking. And this type of problem, I would have you round to the nearest whole foot. So this is so basically we're talking about 78 feet. So 725 feet from the lens, you're dealing with 78 feet in the field of view.
Yes, sir.
All right. So again, I don't know if I said it in this class. I'm about the procedure. As long as you're following the procedure and the only errors you're making are arithmetic errors, rounding differently than I would have, those types of issues, then you don't lose very many points if you lose any at all. Right? Changing a minus sign to a plus sign, which is something I tend to do. Sometimes I won't take any points off, or I'll take 1 point off. If you do multiple mistakes and they're just minor arithmetic errors, you're adding 5 and 9 and you get 15 instead of 14. Well, that's, you use your calculator, okay? If your addition skills or multiplication skills aren't where you want them to be, then use a calculator. You're allowed to. Just write down what you're typing into the calculator. So that way I can make sure that the number you gave me is the number you was the correct number. And then if it's different, then I look at the numbers and try and figure out how you put them in the calculator. Because as you saw in my example here, I ended up multiplying by this number, not realizing I was multiplying by that number because I didn't check the numbers I put into my calculator. Okay, moving on. All right, now we're talking about area of a, what is a sector? And can anybody tell me what a sector is? The easiest way to think about a sector is think of your favorite pie. Mine's pumpkin. Okay. And I cook it from scratch. Oh, I love pumpkin pie. Okay. And you take a piece of that pie. So you have a slice of pie. That slice is a sector. So you got an idea what a sector is?
A sector is basically a section.
Right, but it's a very specific section. Okay, you have a central angle that this angle here, theta. So this triangular shaped part of the circle is a sector. Right? A sector is a thing that has attributes, and one of the attributes is area, because the sector is a portion of a two-dimensional thing. Okay. So a square isn't the area, but the area is an attribute of the square. That's what we're talking about here. So the area of the sector, okay. The area of the sector is A equals 1/2 times the radius squared times theta, where theta is in radians. All right, most of the formulas when we're dealing with circles in this course deal with theta, the angle being in radians. Once around the circle is 2 pi. So if you think of the area of the circle equals 2 pi r squared, right? That's the formula for the area of a circle. But this is the entire circle. What if we're only dealing with a portion of the circle? Well, that's what theta is. Theta is the portion of the entire circle. So, okay. Weird ass cat. There's something outside that's reflecting part of the sunlight onto the ceiling in my living room. And my silly cat is trying to get to it because it just all of a sudden appeared up there and it doesn't understand. And it wants to get it. Okay. Freaky cats. Okay. I love cats. They make my life hell. But anyway. Okay. Oh, I'm over here. So, yeah, for those of you who haven't noticed, Veronica put something in chat. So, yeah, a group study is a good thing to have. Okay. Find the area of a circle whose radius is 3 and the angle is 45 degrees. As we talked about earlier, converted the 45 degrees to radians, it's pi over 4. Okay, so now we do 3. Oh, it's going to be 1/2 3 squared times pi over 4. 3 squared is 9. 2 times 4 is 8. So the numerator is 9 pi and the denominator is 8. And at some point along the way here, you need to convert it to a decimal number because they want you to round it to do decimal places. So you do 9 times pi divided by 8. And so that's what I'm going to type into my calculator. Since there's no decimals, I don't have to worry about screwing up that way. 9 pi divided by 8 gives me a decimal number of 3.534, and the 4 makes it round up to stay at 3. And this is square meters. So my answer here will be 3.53 meter, either meters squared or 3.53 square meters, or 3.53. I can abbreviate square meters to square meters that way. So I will accept any one of these ways of doing it. In my lab, they usually give you the units. They don't, or you select the units. So please be aware, we're finding area, and the area is square units. If they didn't say that it was 3 meters, they said it was just 3 units, then you would have to say square units or unit squared. Unit squared can be written this way, UN squared, this with the square, or you do, or you write out units. Oh, no, units doesn't have an E on the end. That's unite. So square units, that sort of thing. Okay, it disappeared. All right. Well, then this is a good time to say, we'll go through this. All right. And we'll start with linear speed next time. We're not quite done with, and this is, so slide number 28 is where we're going to start up next time. Yeah, we're pretty much at time, so I don't see the point of moving on, starting a new subject area. As you can tell by today's lesson that everything is connected, but it's not a natural progression from one subject to another. We're still talking about circles and angles and degrees and all this stuff, but there's not a natural flow going through this. So it's just jumping from talking about what an angle is to talking about angles on circles, and then sectors and arc length, and now we're going to talking about linear speed and angular speed, and all kinds of fun stuff. Okay. And so we're almost done with section 6.1. So you can go ahead and get in there and start it. Yeah. So yeah, so I'm basically done with y'all. If y'all, if you don't have any questions, you're free to go. If you have questions or you want to listen to questions other people have, go ahead and stick around and ask away.
All right, have a good one, Professor.
Thank you.
Thank you.
Y'all take care.
Bye, thank you.
All right, bye-bye. Oh, thank you, Veronica, for creating that. Oh, she's
Have a
gone
good day,
already.
sir.
You too.
Hello, Professor.
Yes.
Yeah, so I just wanted to talk about degree minutes and seconds again, and the conversion and how everything works.
Okay.
Because like I feel like the way you teach it, the way you're explaining it, it makes it a little bit more simple. So I want to understand like fully how you convert degrees to degrees, how you do the degrees, minutes, and seconds.
So I have 10 degrees. 44 minutes. All right. So we can have up to 59 minutes and
Okay.
59 seconds. Because once we hit 60, we go to the next unit up.
Mhm.
All right. It's like 60 minutes is 1 hour. All right. So that kind of deal. So it's base 60. Thank you, Babylonian. It's the Babylonians that gave us base 60 as far as time is concerned. And yeah, the Babylonians numbering system was base 60. It's wild. All right, and we'll do 20. Oh, wrong symbol. That's, and what did I say? How many seconds did I put there? I don't remember. Oh, let me see. I can find out real quick. Okay. All right, so this is what we have. So I want to convert the seconds to degrees. I mean the seconds to minutes. So I want to go up to the next unit.
Mhm.
So it takes, if I divide here by 60, that turns it to minutes.
Sir, are we supposed to be able to see your screen? I'm sorry.
Oh, you know what? Yes. But it's not showing it. Thank you for pointing that out.
Okay, so 10 minutes.
So to convert to the next unit up, you divide by 60. Because 1 minute is 1/60th. I mean, 1 second is 1/60th of a minute. So if I divide the number of seconds by 60, that gives me the decimal number of a minute.
Mhm.
So this is basically a 1/3 minute,
1/3 of a minute.
which is approximately, and I'm going to go to several decimal places. So that's going to be 0.333. I'm going to go to 4 decimal places. Minutes. So that means 44 plus the 0.3333 is the number of minutes we have.
Okay.
So I want to convert that to degrees now. So again, just like with seconds being converted to minutes, we're going to convert minutes to degrees by dividing by 60 to get the decimal port. So this is a portion of 1 degree. So the portion of degree it is 44.3333 divided by 60 is the proportion of 1 degree.
So can a degree be an equivalent to an hour?
Yeah. If and I think that's something I mentioned earlier, that in the nautical miles, 1 degree is the same, covers the same amount of distance as 1 hour of the sun moving. So the sun moves 1 degree per hour. Actually, it moves faster than that. I'm trying to remember now where they got that from. But degrees in nautical terms is more akin to distance than time. because 1 degree in nautical terms covers 1 nautical mile on the Earth's surface. And so we divide that, we do that wonderful division there.
So when you divide
44.3333. I'm going to put a bunch of threes there.
it equals to
Divided by,
0.73888.
yeah. So that's, yeah, 0.3788. And I'm going to round to a 9 there.
You get 3788.
Oh,
I thought it was a 7.
you are blessed to have a math teacher who's slightly dyslexic with numbers.
No, I'm dyslexic with numbers too, man. Trust me.
Yeah. My mind sees, I have to say it, 89 and 98. In my mind, those numbers are the same number.
Same here.
So I'll say one number when I actually mean a totally different number.
It's funny because I work at a cash register all day, and every time I see, like, I will look at the number and see something completely different. Like, it'll be 2638, and I'm like 8376. Like,
Yeah. Like I have that problem big time. My older brother always like told me like you always have to look twice. Always look twice before you say it out loud, because then it's just like, no, you said the wrong thing. Now you owe this person this money. So
Sir, I solved the 10 degree 44 minute 20 seconds. I think, by the way, the book kind of suggests, which is to divide the 20 minutes by the 3600.
Yeah.
And then add the 3600, or add that
Yeah.
number to the 44 divided by 60.
Yeah, so what they do the 44 divided by 60, that gives us a number of degrees, plus the 20 divided by 3600, again, gives us a number of degrees. So if you prefer doing it that way, great, go for it. Okay.
Yes, sir.
It makes better sense for me to do it the way I'm doing it. That may not be the best way for you. The best way for you might be doing it the way the textbook does it, which is converting everything to decimals in the first place. So doing the 20 divide by 60 and then divide by 60 again, you get 0.00555, just nothing but a bunch of fives at the end. Okay. And then the 44 divided by 60 gives you 0.73, 7.3333 forever. And so when you add the two, you get 0.738888 forever. And so it just depends upon where you're rounding now.
Okay. So now that you broke it down for me, like now that I see it in front of my face, like I understand now. I understand.
Okay. Yeah.
Thanks. I really appreciate it, Coach. I'm about to call you Coach. Thanks. I really appreciate it, sir.
Okay. That's what I'm here for.
Sir, thank you. You have a nice day.
You too.
Before I forget, you said you were going to post a PowerPoint?
Yeah.
Okay.
What I'm gonna do is I'm gonna create it as a PDF file where it has 6 slides per page.
Okay.
So I've had people in the past who have downloaded and printed up the PowerPoints, which is this PowerPoint has 460 slides in it.
That's
Yeah,
a
and
lot
they
of ink
printed
and
it up in
paper.
color, and they used where they had to, where they didn't have a printer, they went to use the school printer or whatever, where they had to pay money for it. That gets expensive.
It's like 5 cents per page.
Yeah. I go, crap, don't do that. What the hell? And well, what she had done is she created a notebook for herself where on one side is a slide and the other side is blank. So as she put the pages in, she put the pages in where the slide was here, and then the blank back side of the next slide is here. And so she would write her notes over here about the slide that we're covering in class.
Mm.
So whatever works for you.
That's cool.
I had thought about doing that where it was 3 slides per page, where they had the slide and then lines over to the side where you could take notes on it. But I think that's too, the lines restrict you what you can write. Gets in the way. So I
Yeah.
like to do the 6 pages, so that way it's less number of pages.
Yeah,
Anyway.
what I plan to do is, because it's a bit fast paced in the Zoom session, and it's hard to follow. It's not really hard to follow, but I find myself that if I try to take notes, that I am not 100% hearing what you're saying, and I'm getting distracted. So what I plan to do is I plan to go back over the PowerPoint and then take notes. And while I'm in the Zoom session, I'll just try to listen and understand what you're explaining.
Oh, okay. Yeah, yeah. Well, and like I had said, I'm going to create a well, I've already created YouTube channels that these videos I'll post in there. And so that's one of the things I'm going to be doing this afternoon, because I need to do that for all 5 classes. So there'll be 2 videos put up into Zoom sometime today or tomorrow.
Alrighty, thank you.
Sir, you have a nice day.
You too. All right. Bye.
Bye, sir.
Oh, I also meant to ask, are you doing a double split screen, double share screen?
Oh, this over here?
Yeah, is it a double share screen?
Well, what it is in Zoom,
Mm-hmm.
there's just the regular share, which puts up
It allows
either-
you to put up more than one.
well, no, where the regular share is just a screen. So you put up the screen you want people to see.
Okay.
Okay. And then there's advanced. Advanced is, I can move this thing around. So what you're seeing is different than depending upon where I put this. And I can change the size of this thing.
Okay. Because what I meant to ask was, if there is a way to have like the PowerPoint, if you're going to drag it to the right anymore, so that your notes can be seen more clearly or vividly?
Oh, these over here?
Yeah,
I can't make this larger.
Okay.
And that's a function of the device I have. And see, if I increase this size, it doesn't make well, it makes it a little, no, it's still the same size. It's just its location is slightly different on the page, on the screen.
Okay.
So this is as big as it gets. If my writing gets too small, or you can't read it, or it's too messy to read, let me know.
Yeah, I just plan to go over rewatch the video and just like pause it, and so I can make sure I get everything.
Okay.
It's no biggie. Alrighty, you have a good day, sir.
All right. You too. All right. And it's a bye-bye. Mm.